Hi, everybody. It's Mark Thurman with the Connected Things 2021 conference. As you all know, we normally do these events live at the MIT Media Lab, but because of COVID, we've done this now 2 years in a row digitally. I hate the word virtually, so I'm using digitally. We have a very interesting fireside chat discussion today with two gents from Qualcomm. I'll introduce them in a second. I just want to remind everybody to keep checking back with us because we're hopeful that we're going to have a fall live Connected Things, maybe a mini conference sometime in the late September, early October timeframe at the MIT Media Lab. And then we will resume our normal rotation springtime, probably late March of 2022, with another Connected Things conference that'll run at the MIT Media Lab, which I note from my speakers is the place where the term IoT, Internet of Things, was actually coined. I think it was by a British gent named Kevin Ashton, by the way. At least he lays claim to it. So first of all, I just want to frame this up. According to GSMA Intelligence, they're forecasting the total number of IoT connections will be a little over 25.2 billion by 2025. Over 5 billion of them will be cellular IoT connections. Right around now, it looks like cellular IoT connections, and that's going to be the focus of this conversation for the most part, are more than 60% of the overall cellular usage. So if you think about the billions of cellular phones that are out there, more than half of the subscriptions, if you will, or the usage will be on cellular versus any other connection like fixed wire or Wi-Fi. No other company has had a greater impact, in my opinion, on the world of cellular communications than Qualcomm. I note for the MIT alums out there that one of the founders, Irwin Jacobs, has MIT roots as well. So we're real pleased to have two gentlemen from Qualcomm. John, I'll ask you to go first and introduce yourself and tell us a little bit about what you do at Qualcomm.
Well, thanks a lot for that introduction. I'm John Smee, VP of Engineering. And then I head up the wireless research at Qualcomm. And so that's where we look at the innovation on technology in a long-term perspective. So we've been working on 5G for over 10 years now, and we're really excited to see where we're at on that commercial traction. And we're continuing to plow 5G research forward, looking at even further applications.
Excellent. So John, thank you. Jeff, I'm not going to call you Jeffrey. I've been told not to do that. Only your mother calls you that, I guess. Jeff, who are you and what do you do?
Hi. No, thanks for the intro. So my name is Jeff Torrance. I'm the Senior Vice President of Product Management. So I'm responsible for some of the products in the IoT business within Qualcomm. If you think about our 2020 numbers, we were in round numbers $16.5 billion of chip revenue, of which $3 billion was IoT. And in Q2 of 2021, the run rate was $1 billion a quarter for IoT revenue.
Wow.
So we have a good business. We're growing quickly. My background was with another company. So I started, if you like, in IoT about 10 years ago. It was a company called CSR, based in Cambridge, in the UK. And we really made a pivot to, sort of move into the IoT space about 10 years ago. And I was on the sharp end of that migration, really from a pure mobile business to an IoT business. And I've been doing the same thing at Qualcomm for 5 years or so.
So wait a minute, there's another Cambridge? That's so confusing. So let's kind of dig in here in terms of 5G and IoT from and John or Jeff, either of you jump in. When you look at 5G, what's the basic overall use case for IoT with 5G? Why don't we just jump in there?
Yeah, maybe I'll take it first from the R&D technology side. And
sure.
So it's something even when 5G was conceived and designed, and a lot of early work we were doing, as I mentioned, around 10 years ago, was this perspective of, well, we need 5G to be about more than the smartphone. And so what does that really mean in practical terms? It means wide area IoT. It also means taking IoT into more critical communication things. We would use the term mission critical, industrial applications. And what's interesting then is this intersection of 5G and IoT is really about many different use cases and also spanning high data rate connected factories, private networks, also all the way down to low power sensors that are maybe transmitting once a day or so. So there really is a continuum of 5G applications for IoT. And it's also something how we design 5G. We needed to make sure it's scaled both up and down in terms of data rates, in terms of latencies, in terms of reliability. So new vectors of KPIs were introduced to make sure that 5G could hit all of these new applications.
So, John, would it be fair to say that 5G is just not another G? I know that's been sort of the trite way of phrasing it, but it's more of an umbrella that has low data rate to high data rate, low latency to a little bit of latency. Is that a fair way to present it?
Yeah, that really it is much more than, as you said, another G. And it's interesting, even when we look at the transformation of communications, you can't do that separate from the transformation of computing, the role of cloud, the role of edge cloud. So when we look at IoT and we look at that 5G intersection and what 5G means, it is the fact that many parallel industries are also evolving and now intersecting with 5G. And so that's exactly right, that it's not just another G, because the global world has woken up to this 5G opportunity, and it's significantly larger than LTE connected smartphones were.
So, Jeff, what's your take?
So I think, building on what John said here, if you try and sort of turn those sort of general trends into sort of concrete sort of things that we see in the marketplace today, first we'll take the scalability. Yeah. So if you like, we've got 5G in a broad sense of modems from our QCX 212, yeah, the lowest end modem, sells in a module for a few dollars, data rates of nominally 100 kilobits per second. And its sleep current is like 1 microamp. So, almost like a Bluetooth capability as a cellular device. And at the other end, we've got like our QCX 315, supporting, 1.5 gigabits per second over the air, 4x4 MIMO, really suited to really high data rate, low latency, and low cost per bit applications. So I feel like we span that whole range from connectivity. What's driving 5G today? I think, the really immediate drivers are cost per bit. So the carriers, because of the efficiency in the protocol, you can start to transmit more data. So applications are very data intensive. Video, for example, 5G is a great use case. So you can imagine sort of wearable cameras, pop-up cameras for safety, security. It's just a space where, really great for IoT. As we go forward, the emphasis on reducing latency really allows people to reorganize compute. So do you want to compute on the edge? Do you want to compute on the cloud? There are benefits of doing on the edge around privacy, dealing with sort of legislative constraints. There are some power benefits, but you don't get the full orchestration. If you can push up to the cloud, you get the full orchestration. And what 5G allows you to do is get that full orchestration, but still have low latency because of the way the radio link works.
So would you describe, if I may, Jeff, would you describe latency as data in flight, in essence?
Not really. I think the way I think about it is it's a control loop. So
okay.
When you sometimes control your mouse and it's like going over the internet and you sort of move the mouse up and it doesn't move, so you move it a bit more, then it moves and it moves again, by which time you've moved it down. I think what 5G allows you to do is get this 1 millisecond latency. And just put that in context, yeah? So when a bumblebee, buzzes its wing up and down, that's like 2.5 milliseconds. So, you can have a closed loop twice with change over 5G for the time a bumblebee raised its wing up and down.
Excellent.
And I would probably add on that when we look at latency on the technology side, we also look at the data rate latency of what's happening, where it's happening. So those questions are now coupled. It's not a question of what computing do I want in the device, what computing do I want at the edge, what computing around the cloud, but how am I connecting those things and how fast am I connecting them? And then there's the other part that's so core to cellular is mobility, right? So people in the early days would talk about handoffs, and absolutely we still talk about that today because we're driving 5G into many interesting industrial logistics centers, these new applications where you want that 5G reliability and low latency, but you also want it in an environment where you're doing handoffs. There may be an AGV in a factory where it's moving through a network that's quite dense, so it's doing handoffs quite frequently. So we also worry about what we call the control plane latency in addition to the user plane latency. So the speed of the data exchange, and then also the fact that the whole thing is coordinated incredibly quickly, and that opens up these more seamless applications.
So as we were talking the other day, I'm imagining there's a conference call, a WebEx, a Teams call occurring. in the C-suite between the CEO, CTO, and various functional leaders, and they're all saying, we're a leader in 5G, aren't we? What are we doing in 5G? So if that conversation is occurring and it's perhaps an industrial company, after that phone call is done, what do you suppose the CTO is going to say and do? In other words, how is he going to leverage the tool that 5G provides and really bring value back to the company? Does that make sense?
Yeah, no, I think I understand. I mean, first of all, I'd say that's not a theoretical conversation by any means. Yeah, I mean, that's conversations that are happening around the world. And I think, really to the earlier point you made, Mark, Qualcomm's shown such leadership in this space. People often turn to us and engage because they know a tremendous amount about their business, but what you can do with 5G, we know about. We don't know a lot about their business. So we have tremendously interesting conversations, with whether that's around logistics and distribution, warehousing, whether that's around manufacturing or utilities or energy or retail, whole bunch of spaces where people see this opportunity to deploy a new fabric to enable different business models that effectively take them down that path of digitization. They want to create a digital twin of their environment, and 5G creates a framework to do that.
So what you're saying is, in a sense, that you're being invited into different kinds of conversations very early in maybe the design cycle or the deployment cycle for an enterprise. Is this earlier than, again, I hate to frame it up this way, but is this occurring earlier with 5G than the other Gs?
It's incomparable, yeah, because when a big distribution center wants to go through a technology transition, nothing to do with Gs, yeah, but it goes and talks to its technology partners, yeah. Qualcomm wasn't at that table when LTE was deployed because it wasn't relevant to distribution centers. As we transition to 5G and the fact that robotics need to be connected over some low latency, high reliable fabric, we are actually at the table and we've got meaningful things to say.
And I think I would also add that one of the things that's different now, Qualcomm's always built these, we're kind of a, if you build it, they will come type of technology innovator. So we take these large foundational risks early, and then we look at these use cases. And as Jeff's saying, it's part of that kind of matchmaking. Say, what are some of the interesting applications? What problem can we solve for a new technology collaborator, whether it's, as you say, industrial, warehousing, medical, et cetera. And so one of the differences is that even our research test beds, for example, we have a smart factory setup. We have a connected vehicle setup. So when we look at IoT and 5G, it was something we recognized. We're not only building test beds because we have to prove out new technologies like millimeter wave, which we did, or new things like massive MIMO for spectral efficiency and coverage. Really, we actually have to prove out the use case. And that's something we can't do alone. So we do have a lot of external engagements and early trials as we're doing this joint wayfinding. What's the best application? And there's the push and the pull. There's the what can you do? What do you want to do? What problem are you solving today? And I would say one other aspect of 5G, it's not a singularity. It's not like, okay, 5G is 2020, and then we're going to ride that exact horse for 10 years. It's something where investing in 5G now is forward compatible. So people don't have to wait. So, oh yeah, 5G is always getting better. Sure, it's going to continue to evolve with new releases, new types of devices. At the same time, 5G itself is forward compatible. So that's kind of the point of the generational big changes from 4G to 5G. 5G was designed with this IoT connectivity in mind. And so then it's going to evolve along with the needs. So going back to the CTO part, they have to say, well, how can I get on the 5G train? Because I recognize those investments are going to seem very wise 3 years from now, 5 years from now, 8 years from now, versus other technologies. So there's that part of, they want to understand what order do they tackle things in.
So John, you're saying it's safe to be the first penguin off the cliff in this particular
I would say that they don't regret taking that step because there's also the fact that it's a huge global ecosystem.
Right.
So in terms of the launch speed of 5G, it's bigger because there's just more money being invested. And because of that, companies who are new to cellular are riding that huge wave of technology innovation and investment that has been going on globally. And so there is that part where someone who's on the industrial side is benefiting from the fact that there's already huge numbers of 5G smartphones.
So what's the kind of, if you looked at the horizon of 5G, and if we're at day 0 or day 1, what's the kind of longer term? I'm not asking what's the when does the next G come about, but I'm asking what's sort of the longevity of where we are. Again, I don't want to go through release 15 and 16 and 20 and all that, but what's from an enterprise CTO or an enterprise CIO perspective, what is the time frame? Because as I know from the IoT world, having been in the IoT world for 20 years, these devices live forever. They live in the field. They're quietly emitting data. They're quietly letting you know that your pipeline is leaking or that there's a security thing because the window's open or whatever the use case is. Your machine is cavitating at the wrong frequency and it's about to spin out of control. Point is, they live for a long time. How long will 5G live from your guys' perspective?
Maybe I should just take that. I mean, you've hit the nail on the head in terms of customer care abouts. You know, mobile phones, I don't know, I'm guessing half the people with a cell phone is less than 2 years old. Yeah, I mean, it's just how it is. So the technology in some ways can be disposable.
Right.
When you look at IoT implementations, devices stay there for a decade or so. And so we actually have people now who could meet the use case with a 4G device, but choose to deploy 5G just for that future-proof benefit. So there's
right.
Cost premium, but if you look from a total cost of ownership point of view, the question isn't when 5G is going away, the question is when 4G is going away, and they buy the option on that long life.
So what's the delta roughly between a 4G, and again, I'm not asking for direct pricing information, but what's the rough delta, either by real dollars or percentage, between an LTE module and a 5G module?
Yeah, it's so difficult to make that comparison. There's features in 5G that you can't have in 4G, you know, at the high end. So I told you about that. We go from the 212 to the 315, you know, you get 100 kilobits to, you know, 1.5 gigabits. It's very hard to make apples to apples comparison. And that's on one axis, yeah? Then I think there's the other axis, how much compute do you want on the edge? So this is a very sort of conflated situation. What is likely, and I think John alluded to this, is because of the scale of 5G, the innovation will drive dramatic cost reduction very rapidly. So if you bet in that space, there's a premium today, but it's going to result in a really good return because you get all the benefits and you get the reduction in cost just from the innovation that comes from scale.
And then you're not getting a letter from your mobile operator saying we're sunsetting the prior 2Gs or 3Gs or whichever.
I've been, you know, as I said, I've been in this for 10 years and we have been through that. We've seen that movie twice. Yeah.
Yeah, exactly. So, John, over to you on, we started talking about how you're having early discussions with enterprises earlier than prior iterations. You're primarily known as a silicon provider. You're not necessarily providing the full package. So how do you collaborate with your ecosystem? Do you come in alone and say, by the way, here's a list of guys you might want to talk to? How do you collaborate with your ecosystem to meet enterprise needs?
And I would say that answer has changed substantially, where today we are looking at end-to-end innovation. And when we look then at partnering on a specific use case, there's so many different, levels of it. And I would say that if we look at partnering for a smart factory, right, we'll have very interesting discussions with companies. And then the interesting thing is the research work, the product portfolio, the sort of service offerings we have. If we look at the evolution, even as you may know, Qualcomm's re-entering the RAN market on the infrastructure side. And one of the reasons is that the networks are now more adaptable. Things like disaggregation and virtualization change how flexible the network is. And even the interfaces on the network are more open. Things like O-RAN are part of how 5G can be implemented. So that disaggregated RAN means that there can be more participants in that network infrastructure provider piece, in particular for a 5G private network. And so there's different ways that we approach that based on the customer desire. Do they want to operate it themselves? Do they want to engage with a system integrator? When Qualcomm looks at its end-to-end capabilities, then there's many different ways we can bring value to that. And I think it kind of goes back to the fact that even when Qualcomm was designing CDMA back in the early 3G days, we were doing so much of that ecosystem and we maintained that core competency. And it's something that's where we do have our end-to-end 5G research test beds where we prove out all these use cases and we do it ourselves. and then we partner selectively. And so then as we're interfacing with Jeff's team and the product opportunity and the services opportunity, then it's really not one size fits all. It's based on where's that mutual value proposition where we have a huge set of assets that we can bring into that.
No, I think I mean, it's amazing, and the market has changed so significantly in the IoT world. All the operators are retooling, hence your discussion on Open RAN. And you touched on private 5G. Just for the audience's sake, can you, yeah, Jeff? I guess I'll go over to you. Give me like a elevator pitch on private network, private 5G, and then the question would be, what's your play there?
Yeah, I probably should go back and just finish on the ecosystem first, to be honest with you, Mark.
Fair
Yeah,
enough.
so I think, what John's talking about is this wave of 5G that's coming ahead. What we've been doing for the last 5 years is taking other technologies and building a channel into IoT within Qualcomm, yeah? So I think it's really important to see this superposition of technology inflection, which is targeted towards IoT, and what we've been doing for half a decade, where we're at something like 13,000 customers within Qualcomm for IoT. So those two things are going to come together. That really will be that is the ecosystem that will create that liftoff.
Yeah, let me break in before you go on to the next. So you mentioned 13,000 customers. I'm not interested in exactly who they are, but there's 850 global operators. So who are the other 12,280, whatever the math is? So are these enterprises or are they cities?
Yeah, I mean, I think what we think at the end of the day, we're a chip vendor, yeah? So we provide chips to OEMs. OEMs provide products that go into solutions. And so what we're trying to do is build the best technology and then enable an ecosystem of people to build the best products on the best foundations. And so we wouldn't see the direct relationship with the carrier for selling a chip. We would see that to a product company that would then sell a device into a solution that a carrier would support.
That's the answer I was trying to get out of you. So perfect. Now go on with the other thing that you wanted to finish, if you still can do it.
Yeah, no, so you asked about private 5G, yeah?
Yes.
I think, there's an opportunity to use the 5G technology, both in the infrastructure and the client end, to reorganize compute. So to make decisions in the most cost-effective, overall sort of system optimized way. And to do that, you've got to have a wireless, so you've got flexibility, reliable, so you don't lose bits, and low latency, so you can move the compute around without breaking your system. And so that's what 5G offers. There are going to be public networks. So there are some applications where public networks probably make tremendous sense. If you want to run an electrical grid, then you want to have compute that's determining loads, and particularly with the electrification of transportation, with microgeneration, you've got to start managing the loads, and you want to be able to do that with accurate and quick compute, and latency is critical, yeah, because you're moving a lot of energy around with those switches. But you've got to have a big reach. You've got to cover effectively the electrical grid. On the other hand, if you've got a warehouse or a factory, you don't need the wide area coverage of 5G, but what you need is that low latency, you need the ability to reorganize compute. And I think what John talked about before is you need to be able to support lots of devices that could be mobile and handing off between one another. There are programs within governments that are making spectrum available so you can run those 5G networks. If you think that's the more economically viable way for you to exploit 5G, by running the network yourself. You can take the license, you can buy the infrastructure, and you can roll out the end-to-end solution. And then, so you can wide area with a carrier, private area yourself, and of course the carriers will often help do that through network slicing or some other technologies.
Or do a hybrid, depending on
exactly
where it is. Yeah, the EU is pretty well acquitted to the licensing of private spectrum. Here in the States, it's CBRS mostly. And I know from my friends in Canada, you can't buy your own spectrum. You've got to team up with one of the operators there. I'm not sure in Asia Pac or what the other regions are like. But no, I think it's super interesting. So if I'm an enterprise CTO, am I calling you to engage in a conversation on private 5G and MEC, edge computing, or are you coming in with an integration partner?
John? I think it's a little bit of both, yeah. I think, at some level, the fundamentals of the technology and the solutions that you can enable is something where you've got to have a deep understanding in the cloud, in the compute, in the connectivity, and the edge. And there are a lot of examples where Qualcomm's engaged directly with people, understanding what can be achieved. And it's it's the same thing. We want to make chips to produce solutions that people can integrate and then deliver the value that they want. But yeah, sure, we need a bunch of ecosystem partners, and that's what I was saying about the 13,000 customers. That includes a load of distributors, system integrators, people who are value-added resellers that make that whole system work.
And I think a lot of people want to come to us first because we represent both that technology view and that use case finding view, and then kind of helping them find the appropriate solution for that connectivity and the compute. And so kind of for Qualcomm, we're thinking end to end, our products are always evolving. And so we're finding that a lot of them are approaching us because they want to start that conversation very kind of jointly brainstorming, we would say, on this intersection. And that's where we're seeing some of that value where they're saying, we weren't really thinking about it this way, but now we've learned something and we're going to come back and talk a little bit differently in the next meeting because we're iterating together.
Oh, I think it makes good sense. And I'm just being mindful of the time as well, not only from your end, but just from the audience's tolerance end after a year and a half of pandemic Zoom calls and Teams calls. And I want to pivot quickly to the pandemic and also kind of end on connected cars, cellular, V2X, V2 everything, V2 infrastructure. So I think we'll try and nail those two quickly. The last year and a half has been terrible, speaking for everybody in many ways, but interesting work styles have now evolved, and we're all sitting here at home working. I'm assuming you guys have some sort of a return to the office scenario at some point in the near future. But how has kind of this COVID era impacted transformation for you, the way you manage your teams, if at all, the way you engage with customers and partners, the way you engage with leadership and your team? So, John, you were just speaking, so I'll have you speak again.
Yeah,
what's been the impact for you?
It's transformed a couple of things. So obviously, one of the interesting things, the ability to collaborate quickly, regardless of geography, right? So that's one of the parts that, using programs like Microsoft Teams, there's this fast aspect of, finding anybody anywhere. And the role then of people interacting and exchanging information at various latencies, not to tie it to 5G itself, but there is that part that being connected and how you're connected and what information you're doing with which medium, I think people have transformed how they approach that. And we've also seen that when we're looking at the transformation, for example, how Qualcomm's approaching our workforce and delivering product in this time, we've also seen other industries drastically change. So a lot of our discussions on the medical side, we've seen that fast change of, hey, we want now a more adaptable hospital. We want to set up field hospitals. We want to be able to change floors from providing one type of medical care to a different type. And that's also opened up new discussions on, mobile medicine, telemedicine. What does that mean in relation to privacy and security and delivery of care, getting the right information to a doctor or a nurse who could be wearing an AR, VR headset in the future. So we've seen a lot of that technology transformation. This kind of people are understanding, wow, there is a huge application space for doing things more flexibly and more quickly and more dynamically. And I think that does relate to not only all the transformations we had to do at a company internally and externally, but even as we see all of this applications of Qualcomm technology is also being, applied into these changing scenarios.
Well, John, as we were saying the other day when we all spoke, I think from my perspective, then I'll go over to Jeff, COVID has really proved out a lot of the core IoT use cases around asset tracking, cold chain, which was it used to be sort of a theoretical thing in many people's mind, but tracking where's my respirator, where's my load of respirators, or where's my COVID medicine. It's got to be kept at a certain temperature. You've got to prove that it's been kept at that temperature. I think recent events have actually proved out some of the key use cases that we've been talking about for 10, 20 years. But Jeff, over to you in terms of your thoughts and managing your teams and all that.
Yeah, first of all, I want to echo the point. COVID's been terrible. Yeah, it's had a lot of personal impact on people. There's a lot of sort of negatives. Yeah, the silver lining, I think, is how humanity figures out how to use technology. And that's in a lot of areas you can see that's the case. Yeah, I mean, getting the home network to work, mesh network deployment, relying on, LTE connectivity. The line between office hours and not office hours has blurred, for good or for bad. The amount of video calls that I do on my cell phone has, increased exponentially during the period of time. Within device, I think your comments about tracking, asset visibility. We as a company are, building the core technology. We're actually starting to sort of work in that ecosystem. Our ventures team have been very active in that space. Video collaboration has grown very quickly. In fact, a lot of the devices you see for video collaboration are in fact Snapdragon powered, using the same technology that you use in cell phones. And then of course the cellular hotspot, another business that's grown and I think is indicative of what's going to happen with fixed mobile access using cellular, in particular 5G technology, where the cost per bit comes down. So as I said, it's been a terrible time for humanity, but that has brought out that resourcefulness to figure out how to use technology. And actually the technology at the center of those transitions is stuff Qualcomm's been investing in for some of it back 30 years, 20, 30 years.
I was going to say the original, wasn't the original offer OmniTrax, for tracking assets and trucks?
Folklore says so. I don't know firsthand.
Yeah, absolutely it was. And that was that point of satellite tracking of trucks. And then we look at that dovetailing into here we are designing 5G V2X and connecting vehicles and smart transportation and smart city and smart intersections. So there's so many things where that fact that, hey, 5G now can connect vehicles to each other, and it can also connect vehicles to roadside units and smart intersections. That's also changing the way, 5G and cellular are applied together for these new applications, because all of a sudden the car is a great example that you're not going to fire up the vehicle. So the vehicle is going to be mobile by definition. And so then the connectivity between vehicles for safety, above the fact that, the vehicle can get network updates, it can get, firmware updates over the air. It can also now exchange positioning and ranging information incredibly quickly to do things related to understanding broader traffic patterns. And so what's interesting, what is known at the network level versus what is known at the vehicle level, and what is that latency requirement for that communication between vehicles. That's where we've seen also a lot of side link applications, which is what the vehicles are using. That's also getting designed and evolved, where you now can use side link for a factory. You can use side link for these other applications. So I think that's the other part, that the connected vehicle era we're in now, that's obviously going to evolve forward to how vehicles are the value of connecting a vehicle is changing relative to an unconnected vehicle. You almost can't buy an unconnected car now. And then as that technology for safety is changing, that also is a great opportunity for Qualcomm.
I think the number I saw from GSMA was 500 million connected cars over the next few years, which is, it's a massive number of cars. And I know in the EU about 2 years ago, they introduced a standard that every single passenger vehicle must be connected, even at a de minimis level, for 911, for e-call, B-call, as they called it. So, it's quite interesting. And we're seeing that, the consumer use cases around putting internet in the car and all the over the top services. But I guess, last question on cellular V2X. Do you see that tied in with autonomous driving? Are they birds of a feather? Are they orthogonal to each other? That's my 50-cent word, by the way.
Yeah, they're not orthogonal, but it is something where the notion of sensor fusion and the notion of communications and radar and positioning, you have to, the ability to exchange information quickly is core to V2X. And then obviously autonomous driving and the different levels of autonomy, that's also based on then ability to predict certain scenarios. And so the ability to see what a camera can't see, right? That's the beauty of RF. So you can see beyond a camera. And so what does that mean then in terms of how you take that information and then you look at what information are you providing to the vehicle or the driver, or in this instance, when can the vehicle make its own decision without the driver also being involved? And so that's where we see that application of V2X in relation to autonomy. So they're not orthogonal. At the same time, they are continuing to both evolve, and there's a lot of work on that intersection related to that, things like sensor fusion and all that stuff.
So this is the notion of, and Jeff will give you the final word on this. The vehicle, all the vehicles in the right-hand lane are notified to move over because an ambulance is approaching in some fashion.
I think
Would
that's
that
a
be a
good
fair
sort
way?
of social benefit to that. I think the other thing is, you know, the sort of the ubiquity of IoT creates massive network effects. And so if the car's connected and the pedestrian's connected and you have, you know, detailed understanding of position and trajectory, you can start warning pedestrians about impact or cyclists about impact. And I think, you know, from a societal point of view, we've really got that massive growth of connectivity. And you learn that at school, yeah. A phone network with one phone isn't much use, yeah. You had a second one, it became infinitely more valuable. You had another one, you know, and so you create this exponential growth. And I think that's where IoT interacts with automotive, interacts with cell phone, consumer electronics. Why IoT is really the fuel to a really exciting connected future.
I couldn't end this any better than with that, other than to that was perfect, Jeff. You'd think we planned this and we scripted it, but it was perfect. So I generally act as the proxy for our audience. So I have to say, on behalf of the audience, I'm certain they will enjoy this or are enjoying this. So I want to thank you both. John, thank you. Jeff, thank you. I want to thank your teams behind the scenes who've helped organize this and cut out any of the bad bits if there are any bad bits. And to the rest of my audience, again, watch our website for information about our get together sometime after Labor Day or early October. And please participate in the March 2022 timeframe at Connected Things 2022, believe it or not. Hopefully we can convince John or Jeff at some point to participate again in the future. But John, thank you very much. Jeff, thank you very much.
Pleasure.
Thank you.
Thanks, Mark.